recording the session. And let's see. Okay, so let's go through 3.1 and see if we can't make sense out of this here. So 3.1 is quadratic functions and models. And so what we have here is the graph of a quadratic function. So when we were doing problems like solving the quadratic, solving equations using the quadratic formula, all that kind of good stuff, these were the types of problems, that type of equation we were using. And what we're going to do is we're going to be rewriting it. So the same equation can be rewritten so it looks like this. And it's f of x equals a, and then in parentheses, x minus h squared plus k. And we have something called the vertex formula. So the vertex, y'all, and I'm going to show you just kind of real quickly so we can kind of understand what the vertex is. When we're graphing quadratic functions, okay, I'm going to put two just real general graphs up here just so you can kind of get the idea. We're going to have two types of graphs. Some graphs they're all going to look like the basic shape. It's going to be kind of like the letter U. And those graphs are either going to open upward, like the way this graph is. So this graph, let me make this a little bit better so it looks a little bit neater for y'all. But the graph will do something like this, or the graph will do something like that, and it'll open down. Okay, and it can be anywhere on the XY axis. I'm just putting them right here, but they can be anywhere on there. And this point right here, if the graph opens up, the vertex is going to be the lowest point in my graph. And if the graph opens down, then the vertex is going to be the highest point of my graph, okay? And there's something called the vertex formula. And the vertex formula is given to us right here, okay? So I got the vertex formula right here. I'll show you how we're going to do it in a few minutes. And then it says, okay, so the graph of f has the following characteristics. It says it's a parabola with a vertex h and k. And then there's something called the vertical line, x equals h is the axis. So what I mean by that is when you look at those graphs, there's basically like a vertical line that cuts the graph directly in half, okay? And that's what we usually call it the axis of symmetry. Symmetry is kind of like when you look in a mirror, you see your reflection, so that's kind of what it looks like, okay? And then how do we know if the graph is going to open up? This means that the number a is positive. So if a is greater than 0, then the graph is going to open up. And that means that a is a positive number. And if a is less than 0, which means a is a negative number, then the graph is going to open down. Excuse me. Okay. So if a is positive, the graph opens up. If a is negative, the graph opens down. And then we talk about wider graphs and narrower graphs. We'll get into that a little bit. The y-intercept, y'all, where it's going to hit the y-axis right up here or right here, is always going to be the point 0 and C. And C is coming from that part right there. Okay. And then we're going to figure out how we can find the x-intercepts. And we'll get to that part in a second. Okay. So, the problem that I have here, and I'm going to kind of come up a little bit, is we want to see if we can match the equation in 1 with the description in 2. Okay, so the first thing I'm going to do, I'm going to write out my basic form. Y equals a x minus h squared plus k, where our vertex is the point h and k. So a couple things I want y'all to notice here. Right here, I have a minus. Right here, I don't. So just kind of like the way we did with a circle, that part that's inside the parentheses, I'm going to change the sign of it. This part here is a positive k, and this part, oh, come on, pen. This part right here is also a positive k, all right? So that one I'm not going to change. So what I'm going to do is I'm going to look at this first equation right here, and I'm going to say, okay, can I find the vertex of that parabola? So if I'm going to find the vertex of this parabola, I'm going to change the sign of that number. So instead of a positive 4, I'm going to use a negative 4. That number will stay the same, positive 2. And remember what we're going to be looking at. The other thing we're going to look at is the number in front of those parentheses. So the number in front of these parentheses is a positive 1, so A is a positive 1. So what we said earlier was, I'm going to zoom out. I know it's kind of hard to see, but I'll come back in. We said if A is a positive number, then our graph was going to open up. And if A was a negative number, then our graph was going to open down. So as I come back over here and I'm looking at this first problem here, I know my vertex is -4 and 2. And since A is positive, this graph is going to open up. So I'm going to say, look, this one here gets matched with C. Okay. And then I'm going to do exactly the same thing for the next one. So I'm going to look at this one right here. And I'm going to find my vertex. Okay. So my vertex, remember, this number, I'm going to change the sign of it. -2. This one stays exactly the same, +4. The number A here, again, is a +1, which tells me the graph opens up. So I'm going to say, okay, which one has vertex -2 and 4 going up? It looks like choice A. So that one's going to go to A. Okay. And then we'll do the same thing for this next one right here. So I'm going to look at this one right here, my vertex, okay? So remember, y'all, the vertex, the first thing I'm going to do, this number is always going to change signs. So instead of a +4, it's going to be a -4. And this number right here will stay the same, +2. And I'm going to look at my number A. Remember, the number A is the number that's in front. Well, the number that's in front there is a -1. That's telling me that the graph is going to open downward. So then I'm going to say, okay, which one has a vertex of -4, 2, and opens down? It looks like choice D. So then by process of elimination, the last one should be D, but let's double check. Okay. So again, I'll do the same thing. Remember, this sign right here, y'all, is always going to change. So the vertex for that one is going to be a -2. This sign always stays the same, +4. The number A in front here, y'all, is a -1, which tells me that my graph opens downward. And as you can see, that one there gets matched with B. Okay. So again, just like we did with the circles, when I'm finding the vertex, I'm going to kind of clean up some of this mess because I know it is a little bit messy. But when I'm finding the vertex, this number, that sign is always going to change. Why? It's inside the parentheses, just like we did with the circle, we changed the sign. So that's why this one here, the first one, had a vertex of -4. Since this one here is not inside the parentheses, that one does not change, okay? And then remember, the number A is, excuse me, the number A is the number that's in front of those parentheses. And in our case, it was a +1, and when A is positive, my graphs are going to open up. When A is negative, my graph's going to open down, okay? So that's kind of how I'm able to figure out which one is going to get matched with which one, okay? So look, let me go ahead and kind of keep scrolling along here, and we're going to do the same sort of idea. It says, consider the graph of each quadratic function, do the following. We want to find the domain and the range. We're going to give the coordinates of the vertex. We're going to give the equation of the axis. We're going to find the y-intercept, and we're going to find the x-intercept. Okay, so let's go ahead and we're going to do this in pieces. Number one is the domain. If y'all remember, the domain refers to the, I'm going to kind of zoom out a little bit so I got a little bit more room to write. The domain refers to the x values, okay? So what does that mean? In terms of the x values, that means is if I were to come back to, here's my x-axis, okay? If I were to pick any point on the x-axis, and I'm either going to have to move up or I'm going to have to move down, but at some point, I want to know if I'm going to hit my graph. So obviously, we know that if we pick any point on the inside here and we go down, we're definitely going to hit our graph, right? And if I move a little bit over here to the left and I go up, yes, I'm going to hit my graph. So the question somebody might say is, well, what happens if I come all the way over here? If I go up, am I still going to hit my graph? Well, I want you to think about what we have here for this graph, y'all. Let me get this pen to be a little thicker. Okay. I want you to think about the way this graph is shaped. It's going up, and it's going up, and it's going up forever and ever and ever and ever, right? So the question is, if I picked this point here and I went up, do you think I would hit my graph? Well, remember, this graph is going up, but not only is it going up, it's going a little bit to the right. So I might have to go all the way even higher and higher and higher, but at some point, we should, I'm going to have to kind of fudge it a little bit, but at some point, we should hit that graph, right? And because this graph here, y'all, I know I'm kind of getting out of the picture, but because this blue graph goes up forever and ever and ever and ever, no matter where we go on the x-axis, if we move to the right, to the left, this way, to the right, or whether we go to the left, no matter where we go, we should be able to hit our graph, okay? So what we're going to say for the domain, we're going to say it's all real numbers between negative infinity and infinity. The domain, y'all, is always going to be from negative infinity to infinity. Okay, anytime I'm dealing with these things, because no matter how far to the right or how far to the left we go, we should hit that graph, okay? Now, we're going to find the range. So the second thing is the range. Oops. Now, the range refers to the y values. So I'm going to come back over here. I'm going to clean up some of this mess because it is a little bit messy. So let's clean up all this stuff here. Okay. And let's look at the range. Now, we said the range were the set of the y values. So here's my y-axis. Yeah, if we move up, the y numbers get really big, like 1, 2, 3, 4, 5, we keep going. And if we come down, the y numbers get smaller. So what I want to do is, when I'm going to look at the range, I'm going to think about like tilting my head. In this case, I'm going to tilt my head to the left, and I'm going to start coming from the bottom up. And I'm going to ask you all a question. What's the first value on the y-axis where we would actually hit our graph if we were to move to the left? So if I were to come right here, say I were to stop at -4, if I were to go to the left, y'all agree that would be the first number we would start off at? Because I'm coming down here from the bottom, and I'm going up, and if I stopped right here and I went to the left, that would be the first time I would hit my graph. And if we kept going up and we go to the left and we go to the left, remember that blue line kind of keeps doing this number. So at some point I might have to go to the right, but what we would start off with would be at -4. So the range, y'all, would go like this, from -4, and if we're going to go up and up and up, we're going to go all the way to infinity, okay? Because I'm thinking about my y-axis. That's why I'm tilting my head to the left, so I can kind of look at the picture and I say, look, if I start coming up, when do I first hit that graph? Right here at -4. And then if I keep going up, I'm always going to hit my graph, okay? So that's what my range would look like, okay? Now, let's get to part B. Part B says, can we find the coordinates of the vertex? So remember, the vertex, y'all, I'm going to look at this part right here. So remember, the way we find the vertex, this number here, that sign is going to change. If it's a +3, the first thing I'm going to do is I'm going to write a -3. This number does not change. So that's going to stay as a -4. Okay. Now, part C says, can we find the equation of the axis? We usually call it the axis of symmetry. What the axis of symmetry is, y'all, is the line that cuts the graph right in half, okay? So look, I'm going to clean up some of this mess because I know there is quite a bit of it here. And again, I want you to think about it. Remember, here was our vertex. The vertex was right there. It's going to be that bottom point since my graph is opening up. The axis of symmetry is going to be the line that cuts this graph directly in half, right here. And that line is going to be x equals whatever the x value of my vertex is. So in this case, it's going to be x equals -3. Okay. All right. Then there is a part D. A part D says, can we find the y-intercept? Y'all, the way we find the y-intercept is everywhere we have the letter X, we're now going to plug in the number 0. This is how I'm always going to find my y-intercept, okay? So what I'm going to do is I'm going to come back to this problem right here, and everywhere I have the letter X, we're going to put the number 0. So 0 plus 3 squared minus 4. 0 plus 3 is 3 squared minus 4. 3 squared is 9, and 9 minus 4 is 5. So the y-intercept, y'all, is going to be a point. And we know that we plugged in x equals 0, and the y number we got was 5. That happens to be my y-intercept. Okay. And then there's finally a part E. So I'm just going to kind of zoom up a little bit or scooch up a little bit. Part E says, can we find the x-intercepts? Okay. So I want you to think about what the x-intercepts are. The x-intercepts are, where does the graph hit the x-axis? So I'm going to kind of do this in red so it comes up a little bit easier to see. Go like this. Here we go. Where does the graph hit the x-axis? Let me ask you all a question. Anybody know what the coordinates of those 2 points are? Remember, points guys have 2 coordinates, right? So we know, for this one right here, what's the x value right there? -5. The y value would be 0. Okay. And then what about for this one over here? What do you think the x value is right there? -1 and 0. There you go. Okay. Alrighty. So look, we're going to look at another problem. We're going to try to go about it the same exact way. So let's see. Here we go. Look at the next one here. We're going to do exactly the same thing. We're going to find the domain and the range. We're going to find the coordinates of the vertex. And let's see. Oh, we've got some more folks here. Good. And we're going to do the equation of the axis, the y-intercept, and the x-intercept. Okay, so let's go super slow so we can make sure we're doing this part right. First thing we're going to find is the domain. So remember, y'all, the domain in every one of these problems in 3.1, my domain is always going to be from -infinity to positive infinity, okay? Because it's telling me that no matter where I pick a point on my x-axis, if I go down, I should hit my graph. Or in this case, if I go up, I'll hit my graph. And no matter where we go, we'll be able to do that, okay? Now, we want to find the range. So remember what the range is. The range refers to the y value. When I measure my y values, y'all, I'm always going to start looking from the bottom going up, okay? So the first thing I want y'all to notice, if you look at this graph that we have here, do you see how we have those down arrows? Those down arrows means that that graph goes down forever and ever and ever and ever and ever, and it never stops, okay? So when I do my range, remember, I'm always going to start from the bottom going up. All the way down here, y'all, we have -infinity, and all the way up here at the top, we have positive infinity. So look, if I'm starting off down here, if I move to the right or if I move to the left, I'm going to hit my graph. And we're going to hit our graph no matter how far we go, except we're going to have to stop at what number? At 2, because once I move to the right, to the left there, I'm not going to hit my graph anymore, right? If I come up here and I move that way, I won't hit my graph. You know what I mean? So again, I'm thinking about like tilting my head like this. I'm tilting my head to the left. And no matter what point I pick, I'm always going to hit my graph, but it's going to stop hitting it at 2. So my range would be from the bottom up to that number, it would go from -infinity to +2. Does that make sense on how we're able to figure that part out? Okay. Now, let's do part B. Part B says, can we find the vertex? Okay. Remember, y'all, in the vertex, that number right there inside the parentheses, that sign's always going to change. -3 This sign always going to stay the same, positive 2. Okay. So there's our vertex. Part C says, can we find the equation of the axis? Remember, this is the axis of symmetry. And to give you an idea, of what that looks like is it's the line that cuts the graph directly in half. So look, that line passes right through -3. So it's always going to be x equals, whatever the x number is right here. Every single time it'll always be that number. Okay. Now, let's try part B. Part B says, can we find the y-intercept? So if I'm looking to find the y-intercept, it's always going to be like this, 0 and some number, whatever y is. So what that means I'm going to do is I'm going to come back to this problem. And everywhere I have the letter x, I'm going to put the number 0. So there's a -2, 0 plus 3 squared, and then there's a plus 2. Okay. So let's see, -2. 0 plus 3 is still 3 squared plus 2. So -2. 3 squared is 9 plus 2. And then, let's see, -2 times 9, -18, plus 2 is a -16. So, again, the y-intercept, y'all, is a point. When x was 0, we came up with -16 for the y number, okay? All right, and we're almost done. Part E, we're now looking for the x-intercepts. So again, if I'm looking for the x-intercepts, I can look at my picture and I can say, look, what are the coordinates here of, let me clean this up a little bit. There we go. So we can see a little bit better. What are the coordinates of those 2 points? So look, if this is -3, what do you think the next one over here to the left would be? -4, right? Okay. So that one, I'm going to zoom out just a little bit so you can see a little bit better. That one is going to be -4 and 0. And then if this one is -3, then the one to the right would have to be -2, 0, right? And those are my x-intercepts, right? So for the most part, y'all, when we're trying to find the x-intercepts, at least with the problems you have in your homework, you can just look at the picture and you'll be able to find those points, okay? It doesn't always work like that for the y-intercept. That's why I'm going through this process right here to find the y-intercept. But for the x-intercept, usually it works out like that. Look at the picture, you'll see it right there, okay? All right, so now let me zoom up or scroll up a little bit. Whoa, that's not what I wanted to do, okay. And let's do the same thing for this problem here. Okay, so it says, given the graph of y equals f of x, answer the following questions. First one says, what is the minimum value? Okay, let me ask you a question. Does minimum mean the biggest or the smallest? What do you think minimum means? Smallest, right? Okay. What they mean by this, y'all, is what is the lowest point on our graph? And when they're asking for the lowest point, they're really just interested here, y'all, in the y value. So if you notice here, that's the lowest point. What is the y value at that point right there? What's the y value? Remember, every point looks like this. X, oops, that doesn't look like an X. X and Y. So we're looking for the second one. So in this case, we're going to say the lowest point or the minimum value is going to be 3. All right. And then it says, for what value of x is f of x the smallest possible? So guys, one thing I want to point out, y and f of x are the same thing. So what this here is asking me is, what is the x value when we are at our lowest point? And we would say, well, the x value here happens to be -3. Okay. All right. And then the next one here says, how many real solutions are there to the equation f of x equals 1? What that means, y'all, is when y is equal to 1. So what I'm going to do here real quick, I'm going to zoom out of there, and I'm going to zoom in a little bit. And we're talking about when y equals 1. So here's y equals 1. What I'm going to do, I'm going to draw a horizontal line right there. This is the line, y equals 1, okay? And I'm going to ask you a question. Does that blue line or that blue graph ever hit the red one? No. So how many real solutions are there? We would say there are none, because those two lines, that red line and that blue graph, never cross each other, okay? That's what they're asking me to do when they say how many real solutions are there to the equation f of x equals 1. Remember, f of x is the same thing as y. So all I did is I just drew a horizontal line at y equals 1. And what we're trying to figure out is how many times does the blue graph hit the red one, and it doesn't, so we would say no solution. Now, look at number 4. It says, how many real solutions are there to the equation f of x equals 4? I'm going to do the same thing. Now I'm going to go y equals 4. So here's 3. This is 4. Okay? I'm going to draw a horizontal line at y equals 4. Okay. And my question to you is, how many times does the blue graph hit that green line? Twice. So we're going to say there are 2 solutions. Okay? I know the way they word it makes it seem like, why do they word it that way if this is really all they're asking? That's just how they word it. So my job is to try to break it down so that we can understand what it is they're asking me to do, okay? All right, so now look, I'm going to keep going over here, and let's see if we can figure out a couple of pieces. All right, so it says several graphs of the quadratic function f of x equals ax squared plus bx plus c are shown below. Given the restrictions on a, b, and c, select the corresponding graph from choices a through f. And it says, hint, use the discriminant. So I'm going to talk to you all what the discriminant is, okay? When we had the quadratic equation, remember this is what the equation looked like? Okay, this piece right here is what we call the discriminant, okay? That's what they got right there, the discriminant. So what the discriminant tells me, y'all, is how many answers we're going to get, okay? How many real answers we're going to get. So I'm going to point something out. I'm going to do this over here on the side. We're going to have kind of 3 case scenarios. The first one, b squared minus 4ac, is bigger than 0. All that means is it is a positive answer, okay? Which tells me that we're going to have 2 x-intercepts, okay? So this is case scenario 1. Case scenario 2 is b squared minus 4ac is equal to 0. We're going to have 1 x-intercept, okay? The third one is b squared minus 4ac is less than 0. That means that the number on the inside of that square root is negative. We're going to have no x-intercepts, okay? And so really what I'm trying to do here, y'all, is I'm going to be looking at kind of these 3 cases as I'm going through my problem, okay? So I'm going to zoom out a little bit so we can kind of get an idea of what's happening, okay? So, oh yeah, it looks a lot better on the big screen compared to my little monitor here. Okay, guys, the other thing I want to mention here, let me do this so that it's a little bit bigger, easier to see, boom. When A is greater than 0, that means my graph is opening up. When A is less than 0, that means that my graph's going to open down. Okay? So, first thing I'm going to do, I'm going to look at problem number 41. Okay? First thing I noticed right here, y'all, A is less than 0. That's telling me, hey, the graph's going to open down. So that tells me I'm either going to choose graphs D, E, or F, right? Because those are the three that are going down. The second thing I notice is look at the discriminant. It's equal to 0. So the graph is going to open down. The discriminant is equal to 0. That tells me that there's going to be one x-intercept. That means that it's going to hit the x-axis. Remember, the x-axis is the one that goes left and right. It's going to hit the x-axis one time. Between graphs D, E, and F, because those are the ones that go down, which is the one that hits the x-axis only one time? E. So right here, we would say this is going to be, make that a little bit better. Come on now, here we go. This here is going to be E. Okay. And all I'm doing is I'm going to just kind of go through each of those pieces to figure out exactly what's happening. So look, I'm just going to kind of go down. I'm going to do 43 next. I'll come back and do 42, 44, 46. But let me look at 43, okay? So look, guys, I'm going to scratch this one out because we've already used it. I don't want to keep looking at that one anymore. 43, A is less than 0. Hey, my graph's going to open down. That tells me again, now I'm either going to choose graph D or I'm going to choose graph E. Look what it tells me about the discriminant. The discriminant is less than 0. If the discriminant is less than 0, I don't have any x-intercepts at all. So let me ask you a question. Between graphs D and F, which one of those not only goes down, but it never hits the x-axis? Which one? Which one do you think never hits the x-axis between D and E? D, right? So for 43, that's going to be choice D, right? Okay. So look, we've used that one. Now look, let's go to 45. Okay, first thing I notice again, oh, look at 45. A is greater than 0. If A is greater than 0, the graph is opening up which way? Up, right? Because A is positive, the graph's going to open up. So that's telling me, hey, I'm either going to look at choice A, B, or C, because those are the graphs that are opening up. And then I'm going to look at this part right here. The discriminant is greater than 0. When the discriminant is greater than 0, that tells me we're going to have two x-intercepts. That means that not only is the graph going to open upward, but it's going to hit the x-axis twice. Which of those graphs, A, B, and C, not only does the graph open up, but it hits the x-axis 2 times? C, right? So that one there is going to be C. Okay. So again, this is really all I'm doing in these problems. I'm just trying to figure out which one is going to get matched with which one, okay? So now look, let's take a look at the same thing. Let's do 42. So I'm going to come back and look at 42 right here. And as I look at 42, first thing I notice, A is positive. Well, if A is positive, my graph's going to open up. So I'm either going to choose A or B because we've already used C. Not only is A positive, but the discriminant is less than 0. If the discriminant is less than 0, we don't have any x-intercepts. So between A and B, which of those graphs opens up, but it never hits the x-axis? A, right? Good. Boom. So we got that one already. Okay. Now, let's take a look at 44. So I'm going to come back over here. I'm going to look at this one. First thing I notice, hey, look, A is less than 0. If A is less than 0, then my graph's going to open down, Charlie Brown. So I only got one more graph that I can choose from that opens down. Looks like it's going to be choice F. But let's double check. Not only does the graph open down, but the discriminant is positive, which tells me we have two x-intercepts. So this graph is opening down, and it hits the x-axis twice right there. So we know that 42 is going to be choice F. We've already used that one. And then, so by process of elimination, guys, 46 looks like it should be B because that's the only one we still got. But let's double check. A is greater than 0, the graph opens up, B opens up, and the discriminant is equal to 0. When it's equal to 0, we have one x-intercept, but not only does the graph open up, but we hit the x-axis once, and there's my answers, right? Did it make sense how I was able to figure these things out? Yeah. So guys, one thing is I had to write this part out first, right? Because that's not necessarily in the notes, but that's why, but like, you know, if you were to watch the video for 3.1, it's me telling you exactly the same thing I'm telling you all right here. But once I know that part, once I know that part, and I remember the part because it was in my notes at the very top of 3.1 that, hey, if A is positive, the graph opens up, and if A is negative, and the graph opens down, then we can kind of figure out some of these pieces, okay? So let's take a look at the next part here. And what we're going to do, y'all, we're going to find the equation of the parabola just by looking at the graph. Okay, just by looking at the graph, we should be able to write the equation of the parabola. So the first thing I'm going to do is I'm going to write the basic form. The basic formula looks like this. Okay, so that's my basic equation. And guys, if it helps, we can even do this. Okay, remember, f of x and y mean the same thing. It's like if your name is Tomas, but they call you Tommy, right? Or your name is Esmeralda, but they call you Esme, something like that. It's the same sort of idea. Okay, so the first thing we're going to do, we want to look at our picture and see, hey, can we find the vertex? Remember, the vertex is going to be either the lowest point of the graph, y'all, or the highest point. So in this case, my vertex is the point 2, -1. So it's 2, -1. So that's telling me that my number h is 2, and my number k is -1. Okay. So look, first thing I'm going to do, y'all, I'm going to write this out. I'm going to write y equals a x minus h, which is 2 squared, plus k, but since k is a -1, I'm going to write it like this. Okay. So there's one piece that we're missing, y'all. The one letter that I don't know yet, I don't know A. But we have another point here in our graph. And look at that point. That point is 0, 0. Remember, this is the x number, this is the y number. So I'm going to put a 0 where the y used to be. I'm going to put a 0 where the x used to be. And now I'm going to solve the equation for the letter A, because that's the only letter that I'm missing. So we're going to go slow here. A, 0 minus 2 is a -2 squared, minus 1, because we still got it squared. -2, when I square it, gives me the number 4 minus 1. Okay, guys, I want you to think about this piece right here. And I'm just going to kind of come up over here because I'm running out of room. 8 times 4, same thing as 4a. Okay, so I don't want to subtract 4 and 1 because I'm really multiplying the a and the 4. Okay, I'm going to move this 1 to that side. That's going to become a positive 1 equals 4a. And then to solve for a, we're just going to divide both sides by 4. And we come up with a is a 1 over 4. So now all I'm going to do is when I rewrite my equation, I'm going to run like this. Y equals, instead of me writing that a, we're going to write a 1/4 x minus 2 squared minus 1. Okay. If we look at the picture, y'all, before I go on to anything else, if we look at the picture, would you say that this graph is opening up or down? Up. Remember what we said. If it's going to open up, my number a should be positive. It is positive. We got 1 over 4. That's a positive number. There's no negatives there. Right? So that's telling me, hey, you know what? We're probably on the right track. We came up with a positive number. The graph opening up. Good one. Okay. So look, let's do the same thing here for this problem. The first thing I'm going to do, y'all, I'm going to write out my equation. Y equals A, x minus h squared plus k. Okay. First thing I'm going to do, I'm going to find the vertex. So here's our vertex. So our vertex in this problem is -2 and 3. So remember what that's telling me. H is -2 and k is the number 3. So I'm going to write this out. Y equals A x minus a -2 squared plus k, which is the number 3. And I'm just going to fix this. Remember, minus and minus all become plus. Okay. All right. Just like we did before, we got to find the number for A. So think about what I'm going to do here. Remember, this point that I have here, that's the x and that's the y number. So where the y used to be, I'm going to put the number -1 equals A. Where the x used to be, I'm going to put the number 0 plus 2 squared plus 3. Okay. And let's see, this is going to be -1 equals 0 plus 2 is 2 squared plus 3. 2 squared is 4. So guys, I'm going to write that as 4a plus 3. Okay. And go this way. Let me write it up here at the top. -1 equals 4a plus 3. I'm going to minus 3 on both sides. So -1 minus 3 is a -4 equals 4a. Then we can divide both sides by 4. And -4 divided by +4 is a -1. So again, y'all, when I get to this step right here, all I'm going to do is I'm going to write it like this. Y equals negative x plus 2 squared plus 3. And all we did is we put, instead of an A, we used the number -1. Again, I'll come back before I go on to the next one. I want you to look at that graph. That graph is opening down. And we said if the graph opens down, then our number A, again, is going to be negative. It was, in this case, it was -1, right? All that last part does, guys, when I'm just doing that part, it's just telling me, okay, I'm on the right track because I should be getting a negative number. If I would have come up with a positive number, that would have told me, hey, you know what, I made a mistake. That graph opens down. Why am I getting, why am I getting a positive number? Okay. So look, let's try another one. We got another one real similar. And let me get a little bit of water. Okay. So let's take a look-see here at this one. I will go about it the same way. All right, first thing, vertex. Vertex is 1, 4. Remember, that's my H, and that's my K. So I'm going to write this out. Y equals A x minus H, which is 1, squared, plus K, which is 4. Okay? And then I'm going to do the same thing we did before, y'all. Remember, this point that I have here, that's the x and that's the y number. So where the y used to be, I'm going to put the number 2. Where the x used to be, I'm going to put the number 0. And we're going to go slow. So 0 minus 1 is a -1. -1 squared plus 4. -1, when I square it, is actually a +1. And 1 times a is just a. So now I have 2 equals a plus 4. I want to solve for a, so I'm going to go ahead and go minus 4 and minus 4. And 2 minus 4 is a negative 2. Okay. And again, we'll do the same thing right here. We'll come to this piece. And instead of me writing that a, I'm going to write y equals negative 2 x minus 1 squared plus 4. Okay. Again, y'all, if I come back and I look at my picture, look at my graph. The graph's opening down, and that's why we got a number a that was negative, right? Does that make sense? Yeah, we're okay. All right. So look, I want y'all to help me with the last one, because I think after this, yeah, we got something kind of the same, but a little bit different. Okay, so let's take a look here. Remember, the first thing I'm going to do, y'all, this is what I'm going to write. Y equals a x minus h squared plus k. Okay. So remember, this is my vertex, right? So that's my number h, and that's my number k, right? So let's go slow. A x minus, what is the number h? Anybody know? Negative 1, right? There you go. Yeah, let's go ahead and fix that. Remember, since it's minus minus, y'all, it's going to become plus. And what's our number k? There you go. You got it. Okay, then the second thing, y'all, remember, this is my x, and this is my y, right? So let's go slow, and let's see. Where the y used to be, I'm going to put a 0. Where the x used to be, I'm going to put a 1. So that's 1 plus 11 squared minus 12. Okay. Not plus 11, but it was plus 1, wasn't it? Oops. Fix that. Plus 1 and plus 1. Okay. Oops. Keep writing the wrong numbers. All right, let's go slow. So let's see. Let's see. 1 plus 1 is 2 squared minus 12. Let's see. 2 squared is 4, so that's 4a minus 12. Okay. I'm going to go ahead and add 12 to both sides. So over here, this is going to give me 12 equals 4a, because I'm adding 12 to both sides. And then we'll divide both sides by 4. Anybody know how many times 4 goes into 12? 3 times, right? Good. We got this part here. So y'all, just like we did before, I'm going to come back to this part right here. And instead of me writing the letter A, we're going to write the number 12. So we're going to, or the number 3, I'm sorry. So 3 times x plus 1 squared minus 12. And here's my equation. Okay, so guys, the next thing I have, same exact problem, but it's in the form of a human cannonball, right? So let's take a look here. We got some information, and I'm just going to kind of read it a little bit to you guys. And it says, as the countdown begins, David Smith Jr., the bullet, dons his safety helmet, slides down the slender barrel of his cannon, positioning himself to become a human projectile. The crowd joins in the countdown, and the announcer asks the audience to cover their ears as protection from the noise of the blast. 3, 2, 1, fire. David Smith Jr., aka the bullet, blasts into air, flies an average distance of 160 feet and a height of 60 to 70 feet, and lands in his pre-positioned safety net. This death-defying feat guaranteed to send shivers down your spine. What we're going to do, y'all, we're going to figure out the equation that describes the path on how he got shot out of a cannon. Okay. So first thing we know a couple of things. We know that he was shot a distance of 160 feet. So from one point to the next, like on the x-axis, he went 160 feet. And it says he reached a height of anywhere between 60 to 70 feet. So I want to show you what we got here. Let me see. Oh, okay, I didn't do it. All right, so I'll show you. We're going to do this real quick so we can see what's happening. Here is how he's being shot. And it goes like that. This distance here, y'all, is 160 feet. It told me that the height that he reached was, let's go with a bigger number. Let's go with 70. Think about this. This looks like a parabola going down. This is my vertex. So let me ask you a question. If this number here is 0 and this number here is 160, anybody know what's between 0 and 160? What's half of 160? 80. That number there is 80. So y'all, if I were to think about this as a point, it would be 80 and 70. Okay? So look, we can start writing out our equation. I'm going to do it just like we did before. Okay? And so look, we're going to go real slow. X minus 80 squared plus 7. Okay? So if I were to think about the coordinates, say, of that point right there, wouldn't the coordinates of that point be 0, 0, right? So remember what that means. That means that wherever I have a y, I'm going to put a 0. And wherever I have an x, I'm going to put a 0. Okay. So again, I'm going to go super slow here. 0 minus 80, negative 80 squared plus 70. Negative 80, if I square that, if I take my calculator, y'all, and I say, what's 80 times 80? It's going to be 6,400 plus 70. And then I'm going to take this 70 and I'm going to move it to the other side. It's going to become a negative 70 equals 6,400 with an A. And then when I divide both sides by 6,400, the only thing I'm going to do here, y'all, is say, look, I can cancel this 0 with that 0. So my A is a negative 7 over 640. Okay? So now, when I come back to look at this equation right here, I can say, look, y equals negative 7 over 640 x minus 80 squared plus 70. And there's the equation that describes his path, right? And again, remember, he's being shot out of a cannon, right? So somebody might say, okay, well, what does that really look like? So let me see. Oh, somebody put something in the chat. There you go, Father. You were telling me. Excellent. Thank you so much. So let me do this real quick, and I'll share the screen with you guys too. Oh man, how do I get out of here? That's not really what I want to do, but we'll do it this way. And no, I don't want that either. Let's go like this. We'll just do a general search. And let's go David Smith Jr. Human Cannonball. All righty. So let me share this with you guys watching at home. And let me go like this, and like this, and like this. So we can see, what does it look like to get shot out of a cannon?
Time tracking is fun.
Oh, man.
Said no one ever.
Right?
That's why we designed Connect Team's time clock to simplify.
All right, so here he is, guys. This is the guy who gets shot out of the cannon. So do you see how his path looks like that parabola? Right, it kind of does that same thing, right? And he's got the little helmet cam, right? So then I'm going to show you all one more video. And, huh? Oh, yeah. Let me go like this. Let's see if we can find it. Where is it? Where is it? Where is it? Let me see if I can find it. Here we go. So the question is, and I saw somebody put something in the chat. Let's see what they put. So the ring of fire would be the vertex. That's exactly right. Exactly where they. So guys, if you can see Antonio's comment, the ring of fire would be the vertex. That's right. That point, whenever he reaches the highest point, that would be the vertex. You're right, Antonio. Good observation, man. So the question is, how does somebody become a human cannonball, right? The way you become a human cannonball is your dad is also a human cannonball. So the guy that we just saw get shot, this is his dad, y'all. And this is his dad being shot across the border in California, San Diego, or actually he was in Tijuana, and he got shot into California, San Diego, in the southern border of California.
Got my passport.
Your passport?
Yeah, there.
How was the jump?
Good.
Is it
Cake.
what you expected?
Yeah, it's easy. It's all right.
By this time, did you find out what was going on? Why did you jump?
For money. I get paid.
So there you go. So he got shot out of a cannon, dad, right? And they asked him if he had his passport. He says, yeah, I carry my passport when I get shot across the border. So, guys, I've been doing this for a long time. And back in the day, there used to be this show on MTV called Jackass. And it was like these people did all these real stupid things, you know? And so when that show was popular, like so many years ago, I used to say, this is college algebra on Jackass or whatever. But anywho, I just wanted to show you guys that because I always thought it was kind of neat. So let me stop sharing this screen here. And guys, we still got a little bit of time. We got some time. So you know what? Let's go through a little bit of 3-2. We may not get through all of it, but we can at least do part of it. I'm just going to kind of take a quick scroll and show you guys how we can at least do part of 3.2. It is kind of a long section. So guys, for this week, y'all have 3-2 or 3-1, 3-2, and 3-3. Remember, they're not due a week from today. They're due on Thursday, which would be the, what date? 21st? That's when they're due, right? So you got plenty of time. So like next Tuesday, guys, I'll be able to answer questions, that kind of stuff. But let's at least do a little bit of 3-2, okay? So let me come back over here, and we're going to do 3.2, which talks about this thing called synthetic division. And so I'm going to kind of show you how we can do synthetic division. I'm going to show you what we call like long division, and then I'm going to show you what we call synthetic division. Okay, so first what I'm going to show y'all is using what we call long division. So long division, y'all, is exactly that. Look what we're dividing by. We're dividing by x plus 1. And we're dividing x to the third plus 3x squared plus 11x plus 9. So let's go like this. X to the third plus 3x squared plus 11x plus 9. Okay, so we're going to divide like the way we used to when we were back like in junior high, elementary school, whatever it happened to be, right? Okay, what I want you all to think about for a second is, look at what I have right here. I have an x to the third. And look what I have right here. My question to you is, what do I need to multiply x by so that I would get an x to the third? Anybody know? What do you got to multiply an x by to get an x to the third? We need to multiply it by an x squared, right? Now I'm going to show you why do I need to multiply it by an x squared. So look, we're going to go real slow. X squared times 1. I'm sorry, x squared times x to the third. Sorry about that, y'all. Right here, x to the third. X squared times 1 plus 1x squared. Okay. Now, when we divide, remember what we do now? The next step in dividing is we have to subtract. So I'm going to put a minus in front of here, and I'm going to put a minus in front of there. I got to subtract the whole thing. So look, this x to the third and that x to the third are going to cancel out. A 3x squared minus 1x squared is going to leave me with a 2x squared, and then I'm just going to bring down that plus 11x. Okay, Again, guys, this is long division. I'm going to show you the shortcut in a minute. I just want y'all to see what it looks like, okay? Now, I'm going to play that same game we played a little while ago. I'm going to ask myself, what do I need to multiply x by so that I would end up with the 2x squared? And I would say, look, why don't I multiply x by 2x? Because 2x times x leaves me with a 2x squared, right? And 2x times 1 leaves me with a 2x. Okay. Remember what we're going to do now. We're going to subtract. So I'm going to subtract that one, and I'm going to subtract that one. Okay. So look, these 2x squareds will cancel. 11x minus 2x is going to leave me with a 9x. And then, y'all, I'm going to bring down this plus 9. And I'm going to do this one more time. I'm going to say, what do I need to multiply x by so that I would get a 9x? Okay, look, let's just multiply it by 9. So 9 times x leaves me with a 9x. And 9 times 1 leaves me with a 9. And I'm going to subtract. And I'm going to subtract again. And those 9x's are going to cancel. And those 9's are going to cancel. And so that would be my answer. X squared plus 2x plus 9. That's what we get when we divide this out. And guys, this is what we call long division. And you can see why we call it long division. It takes a long time to get it done. Okay? Now, instead of us doing it like that, we can do something called synthetic division. Synthetic division, y'all, my box is inverted. Okay, so it looks more like this. What I'm going to do is I'm going to use the numbers that I have here without me writing the x's. Okay, so my first question to you, what is the number in front of the x to the third? 1. What's the number in front of the x squared? 3. The number in front of the x? And the last number is a 9. Okay. All right. Guys, second thing. Do you remember when we were doing this step, we had to subtract, so we would go minus and minus. We had to subtract, we're going to go minus and minus. We got to subtract, we're going to go minus and minus. So that we don't have to keep doing that, what we're going to do, we're going to take this number right here, and we're going to change the sign. So I'm going to put a -1 on the outside. I know it says +1, but we're going to change the sign. Okay, the first step always in synthetic division is take this first number and bring it down. So that first one, it just drops right down, okay? Second thing we're going to do, y'all, we're going to multiply. -1 times +1 is a -1. What we're going to do now, y'all, we're going to add. What is 3 minus 1? 2? We're really adding because it's 3 plus a -1, but I know there's a minus there, okay? We're going to do the same thing again. We're going to multiply. -1 times 2. What's -1 times 2? -2. And we're going to add again. So 11 plus -2 is 9. And then we're going to multiply one more time. -1 times 9 is a -9. We're going to add those numbers again. We're going to get 0. Okay? So let me tell you what's going to happen. This number is my remainder. We don't have a remainder because our remainder ended up being a 0. If you look at the original problem, y'all, the original problem had an x to the third. But because we're dividing it by a polynomial that has an x, what we're doing is we're reducing the power of that x to the third by 1. So instead of me having an x to the third polynomial, now I'm going to have an x squared polynomial. This number is telling me the number in front of the x squared. This number, it's a +2. That's telling me the number in front of the x. This number is telling me the constant term, the one that does not have an x. It's a +9. And I want you to look at my answer here. And I want you to look at the answer we got when we did long division. Didn't we get the same answer either way? But wasn't synthetic division a lot faster? Okay, so the only reason I showed you guys long division is so you can kind of visually see what it was we did. but I'm never going to have to do a long division problem because I'm always going to go with synthetic division. Okay, that's going to be kind of my idea. But I wanted to make sure that we understood why it works the way it works. Okay. So let's try the next one. We're going to go synthetic division again. Okay. So remember, y'all, first thing I'm going to do, I'm going to draw my half box. It looks like this. And then I'm going to put these numbers here without the x's, just the numbers. So 5 is the number in front of the x to the fourth. 5 is the number in front of the x to the third. 2 is the number in front of the x squared. -1 is the number in front of the x. And -3 is the constant term. Remember, what I'm going to do with this sign right here, that number, I'm going to change the sign of it. I'm always going to change the sign of it, okay? So this is now going to become a -1. First step, always, always, always drop down that number right there. Okay? Second step, now we're going to start multiplying. -1 times 5, -5. We're going to add those numbers together. That's a 0. We're going to multiply again. -1 times 0, still 0. Add them together. That gives me a 2. Okay. -1 times 2 is a -2. We're going to add those numbers together. -3. And again, we're going to multiply one more time. -1 times -3 is a +3. We're going to add them together. That's 0. Y'all, the last number is always telling me my remainder. We don't have a remainder here, okay? So now, I want to think about what it is we have. We used to have an x to the fourth polynomial. We're going to reduce it by a power of 1. This is telling me the number in front of my x to the third, okay? What's the number in front of the x squared? 0. So if 0 is in front of the x squared, I don't got to write it down, y'all. This is telling me the number in front of the x, and that's my constant term, okay? So because we have that 0 there, I don't have to fill that number in. I'm not going to put like 0x squared. I'm just not going to write it, okay? All right. Let's try the same thing for this next one. So I'm going to go again real slow just to make sure I'm getting the idea. Here's my half box. Can you tell me what numbers I should write on the top? Anybody know? What's the first number? But the number here is just 1, right? And then 4, 2, 9, and 4. And then what number is going to go over here? The -4, right? We're always going to take that number right there, y'all, and we're going to change the sign. So 1, 4, 2, 9, and 4. Remember, step number 1, y'all, always going to bring that first number down. There it is. Now we're going to multiply. -4 times 1 is -4. We're going to add them together. That's going to give me 0. -4 times 0 is going to give me 0. We're going to add those numbers together. That's going to give me 2. We're going to multiply. -4 times 2, -8. We're going to add those numbers together. That's going to give me a 1. We're going to multiply one more time. -4 times 1 is -4. We're going to add them together. That's 0. Remember, the last number, y'all, always my remainder. Okay, so remember, we used to have an x to the fourth polynomial. This is the number in front of the x to the third. That's the number in front of the x squared, so I don't need it. Plus 2x plus 1, and there's my answer. All right. So again, the process, guys, always going to be the same, okay? Every single time. Okay. Now let's take a look here at the next one. We'll go about it exactly the same way. Let me get my half box. Remember, -9, 8, -7, and 2. Y'all, one thing, don't forget the signs of those numbers, right? So if there's a negative in front of the number, we got to write the negative down, okay? If there's a minus there, we can think about it as a negative number. Now again, remember what it is I'm going to do here. I'm going to come back over here. I'm going to say, look, that number right there, I got to change its sign. So if it's a -2, I'm going to put a +2. Okay. And then I'm going to bring this one down. That's a -9. Let's start multiplying. 2 times -9, -18. We're going to add those together. That's going to give me a -10. 2 times -10, -20. We're going to add those together. That's going to give me a -27. And let's see, we're going to multiply again. 2 times -27, -54. And if I have $2, but I owe you 54, I'm still going to owe you 52. This is my remainder. All right, so let me show you how it is I'm going to write my answer out, okay? Remember, we used to have an x to the third, so now we're left with an x squared. So this is going to be -9x squared minus 10x minus 27. Since our remainder is a -52, y'all, we can go like this. -52 over, what were we dividing by? We were dividing by the original part on the bottom said what? X minus 2? That's what it looks like, y'all. Okay? And I want to explain to you, why do I need to put that X minus 2 on the bottom? Think of an easy division problem that we used to do probably back in either junior high or maybe even elementary school. Something like this, 9 divided by 2. If I was going to do this old school division like this, we would say 2 goes into 9 4 times, that's 8. Remember, we subtract, my remainder is 1. So sometimes we used to write it like 4 remainder 1, or sometimes we'd write it as 4 and 1/2, because I'm dividing by 2, here's my 2, right? And remember, like improper fractions and mixed numbers, we could say, look, 2 times 4 is 8, plus 1 more is 9. So we're kind of doing the same thing here. We're taking our remainder and we're putting it over whatever we were dividing it by. In our case, we were dividing it by an x minus 2, okay? So that remainder, y'all, is always going to go over the original denominator with the x and everything in there, okay? So let me try another one. We got 2 more like this. Again, we'll do the same idea here. 1, -3, -4, +12. I want y'all to notice something. Do you see how there's no number that doesn't have an x? Like there's no like +5 or -3 at the end? That really means that the number at the end, y'all, is 0. Okay? And then we're going to do the same thing we did before. We're going to take this number and we're going to change the sign +2. Okay? So let's go one piece at a time. Remember, first thing, drop down the 1 and multiply. 2 times 1 is 3. Add them together, that's 0. 2 times 0 is 0. Add them together, that is -4. I'm sorry? I'm sorry, I just can't hear you. Let's see, hold on. So let's go like this. I'm just having a hard time hearing you from back there, but let me go like this. Let's go here, 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 here. Okay, let's see. So bring down the 1. We're good so far? Okay. Oh, okay, okay. So let's see. Oh, I put a 3. That's what you're saying. Yeah. Okay, I see what you mean. Yeah, you're right. My bad. Oops. Okay, you're right. So -3 and 2, you're right. I'm sorry. -1, right? Now we can go ahead and multiply. So 2 times -1, -2. Very good. We add those together. That is a -6. 2 times -6 is -12. Add those together. That's 0. And 2 times 0 is 0. Add those together. We got a 0 here too, right? Okay, so remember, y'all, this is my remainder. We obviously don't have a remainder. Remember, we used to have an x to the 4th. So this is telling me the number in front of the x to the 3rd. That's telling me the number in front of the x squared. And that -6 is telling you the number in front of the x, and there are answers. Okay. So yeah, no, you're right. That was my bad. All righty. So look, we got another one here, similar. First thing I'm going to do, y'all, I want us to look at the top part, right? And remember, when I draw my half box, remember the number in front of the x to the third is 1. If you notice here, y'all, do you notice how there's no x squared term? If there's no x squared term, but we had an x to the third, that means the number in front of the x squared really is 0. And if I look back again here at the top and I say, you know what, not only is there no x squared term, but there's no x term either, that means that the number in front of the x is 0 also, and then the last number is -1. And I need to write it out that way because we're talking about kind of like placeholders, you know what I mean? So I need to put those numbers in. If they're not there, that's okay, but I got to fill them in with zeros. And then, let me get my eraser, and let's come back and take a look at the bottom part. Since that bottom number is a -1, remember, I'm going to put a +1 right here, right? And first step, y'all, we're going to drop down the 1, and we're going to multiply. So 1 times 1 is still 1. We're going to add them together. That's 1 again. 1 times 1 is still 1. We're going to add them together. That's 1. And 1 times 1 is 1. And -1 and 1 is 0. Remember, that's my remainder. So remember, we used to have a problem that had an x to the third. So this is now the number in front of the x squared. This is now the number in front of the x. And that is our constant term. It's really, really important that I put those zeros there. And the easiest way to kind of understand why do I need to put those zeros there, you know, as we've been doing these problems, y'all, I was telling y'all, like, okay, remember when we used to divide when we were like in junior high or elementary school? Think about it like this. If I had $5 and I owed you $1.83, wouldn't we write it like this? 5.00, 1.83. Isn't that how we used to do that back like in elementary school? So even though there were no zeros here, we put them because they're like those placeholders. That's kind of the idea right here. Even though they're not there, I'm going to put them in because they're going to line up those numbers that need to be lined up, okay? So that's usually like the easiest way I can explain that idea. So as you're doing your problems, y'all, if you notice that it goes, I'm going to make this up. If you notice it goes from an x to the fifth down to an x to the third, that means we're missing the x to the fourth, so we got to put a 0 where that x to the fourth would have been, okay? That's kind of the idea. All right, so look, let me zoom out a little bit more, and we're going to talk about something called a special case of the division algorithm. And it says, use synthetic division to divide f of x by x minus k for the given value of k, then express it in this form. Remember a little while ago when I said, what is 9 divided by 2? And we came up with like 4 and remainder 1. We came up with something like this. And I would have said, okay, like how could I rewrite 9 using the numbers 4, 2, and 1? So we might say 9 is 2 times 4 plus 1. So I know we were taking 9, we were originally dividing it by 2. We came up with 4, the remainder 1. So we could check our answer by saying, well, 2 times 4 is 8. Add 1 more, and you get the original problem 9. We're going to kind of do that with this part right here. And I'm going to show you how we're going to do this, okay? So number 1, we're still going to use synthetic division, okay? First thing I'm going to do, y'all, draw my half box. These are the numbers I'm going to use. So I'm going to put 2, 1, 1, and -8, okay? Second thing is, I want us to look at this part right here. It says k equals -1. So the problems that we had before, I'm going to kind of scroll back to the problems that we had before. When we had something like this, it was in the form x minus, or we had one before, it was x plus, and we would change those signs. Whenever it was a plus, we put a minus. If it was a minus, we put a plus. When it's in the form k equals a number, the really important part here, y'all, is that it has the equals to. If it has the equals to, the sign has already been changed for us. We don't need to go through that part, okay? So this is what we're going to do now. We're going to do synthetic division just like we've been doing. I'm going to bring down the 2, and we're going to multiply. So negative 1 times 2, negative 2. We're going to add those numbers together. 1 plus negative 2, negative 1. We're going to multiply those together. That's a positive 1. We're going to add those together. That's going to give me a 2. Negative 1 times 2 is negative 2. We're going to add those together. That is a negative 10. This is my remainder. Okay? So this is what we're going to do now, y'all. We're going to write our problem so that it looks like this. So we're going to say f of x equals, let's see, x minus k. So I'm going to write this as x minus k, which was a negative 1, times this piece right here. Remember what we used to have? We used to have an x to the third polynomial. So remember, that 2 is telling me that's the number in front of the x squared. This negative 1, that's telling me that's the number in front of the x. This 2, that's just a constant number, and then it says plus r. R in this case was a negative 10, so I'm just going to write that as a minus 10. And then, y'all, the only thing I would probably do here, since it's minus minus, I'll write it as plus. And that's just me rewriting this problem here like this, and it's kind of like saying, remember when I said we had 9 divided by 2, and the way we could check that out, we would say, look, we would go 2 times 4 plus 1. It's kind of like saying this part right here is equal to all of that if you were to multiply it and then subtract 10. And I know it's like real ugly and it's got a lot of these x's and everything, but the idea is it's kind of the same, okay? It's kind of rewriting how would I get 9 from 2, 4, and 1, multiply 2 times 4, add 1, multiply that x plus 1 times the 2x squared minus 1x plus 2, subtract 10, you'd get the original problem. That's all it's kind of showing you. So it's kind of saying that stuff we used to do in elementary school or junior high, you can do it also to polynomials, right? And you're like, why would I do that? I don't know. Somebody somewhere said, let's try it, and it worked. Okay. So look, let me do one more problem, y'all, and then we'll call it a night. And so we have something here called the remainder theorem. And the remainder theorem says, if I want to find f of a value, we can do it using synthetic division, and whatever the remainder is, that's the same thing as evaluating my function at this particular point. So I want to show you something that we have here. I'm going to do, number one, I'm going to do a little stare and compare. I have f of k, I have f of negative 3. So what that's telling me is that k equals negative 3 just by looking at this and like that, okay? Second thing is, I'm going to do my synthetic division. So I'm going to use my numbers that I have here. The number in front of the x to the 4th is a negative 1. Guys, that's the number in front of my x to the 4th. Do we have an x to the 3rd power? So I got to put in a 0 there, okay? Kind of again like placeholders. The number in front of the x squared is a 3. The number in front of the x is a negative 4, and the last number is a negative 5. Okay, now the number that I'm going to put right here is this number. Since it's already in the form k equals, the sign has been changed for me, okay? So now, remember, first step, we're going to bring down the negative 1, and we're going to multiply it. Negative 3 times negative 1, positive 3. We're going to add those numbers together. That's going to leave me with a 3. Negative 3 times positive 3, negative 9. We're going to add these numbers together, minus 6. Okay. Negative 3 times negative 6, positive 18. We're going to add those numbers together. That should give me a 14. We're almost done. Negative 3 times 14 is a negative 42. We're going to add these numbers together. We're going to get negative 47. Okay, what the remainder theorem says is, think about before y'all how we used to find f of negative 3. Wouldn't we come back over here and everywhere we had the letter x, we would plug in the number negative 3? What the remainder theorem is saying is, instead of you doing that, if you want to find f of negative 3, it's whatever the remainder is. So instead of me having to do this problem by everywhere I have an x, plug in the number negative 3, raise it to the 4th, put a negative 1 in front of it, take negative 3, square it, multiply it by 3. Instead of me plugging in a negative 3 everywhere I have it like that, we can do it like this, and then just find the remainder, and there's your answer. That's all the remainder theorem is telling you, okay? So look, let's try one more with the remainder theorem, and then we'll call it a night here, y'all. So I'm going to do the remainder theorem. I'm going to do it exactly the way we did before. Okay. So look, let me put a 1, a negative 4, a 2, and a 1 right there. I don't have any missing pieces. We go from x to the third to x squared to x, and then our regular number. The sign has already been changed for me because it's in the form k equals. So my negative 1 is going to go right here. So first step, bring down the 1, and we multiply. Negative 1 times 1 is a negative 1. We add them together, that's a minus 5. We multiply. Negative 1 times negative 5 is a positive 5. We add those numbers together, that gives me a 7. We multiply again, negative 1 times 7, negative 7. We add these numbers together, that's a negative 6. Okay? So, look at what the directions are asking me to find. They're asking me to find f of k. And in this case, k is the number negative 1. So f of negative 1 is just negative 6. It's always going to be the remainder, every single time. Okay? All right, so guys, remember what I said, 3-1, 3-2, 3-3, they're not due this Thursday, they are due the following Thursday, right? So again, next Tuesday night, y'all, I can answer questions. We can continue with 3-2, we can do 3-3, right? My recommendation is between now and Tuesday night, try to do as much of 3-1 and 3-2 as you can do, okay? And then we can answer some questions from 3-3, all that kind of good stuff, so that next Tuesday night, you know, we can kind of answer questions and figure out what we need to do, all right? So there's still a little bit left in 3.2, but I don't think there's 2 more problems to do. That's it. So we've done almost everything. All right, and I'll give you a hint. For these last 2 problems, if it says, if it's a 0, all that's going to tell you is the remainder is 0. And if the remainder is not 0, then that number is not a 0. Okay, so there's not much left in 3.2, but we did all of 3.1, we did almost everything in 3.2. Y'all just got 2 problems left to do. And we can continue next Tuesday, right, answering questions and that kind of good stuff, all right? So let me stop sharing this here. And those of you who are at home, I'm glad you were able to join. And guys, I'm going to stop.